All right. So yeah, just a quick summary while we're here. We had finished writing up the RCA regarding the current outage across both ISPs. I realized I forgot to include it in the meeting invite, but I did send it a short while ago. So hopefully you have access to it now. But if you like, I can share the screen here as well. We can go over it. Let's see.
Thanks.
All right. Can you see my screen okay?
Yes. Just a bit
The-
small. Maybe. Oh, yeah, that's good. That's better.
Okay. So yeah, what I wanted to highlight and go over with this RCA is, help clarify ultimately what happened, what was the cause, what we can do to address the issue, and also what in a sense what can't be done to fix the issue as well, right? I think over the course of the past couple of weeks, various individuals, myself, and everyone, we've all contributed or had conversations around this. And I think I'd like to kind of, summarize where we're at and the action steps that we can take. So
Yep.
The TLDR here, I think you're all aware of. There was a physical outage with Colt and a performance issue over the Momentum circuit. I believe there was some confusion about how the backup between the two circuits work, and we had received inquiries from leadership regarding, if we're doing efficient backup and testing of the circuits. And I believe there might have been confusion about what the SD-WAN does and how that works. So to clarify, before we had implemented SD-WAN at the site, you had what was considered a active passive circuit arrangement, meaning the failover of circuits could only occur if there was a complete physical outage, such as we saw with Colt. When we traditionally did backup failover testing for these circuits in those previous architectures, we would conduct annually a testing of the circuits. A while ago, we enabled SD-WAN on the two ISP circuits, and what that's had allowed us is to enable what's considered an active-active circuit scenario. Now, that term can be a little misleading because, in a sense, only one circuit is still active, as in it's passing local site traffic over an ISP at a time. The active-active comes in the scenario, in the sense that instead of once a year there being a backup test, this is happening hundreds of times a minute through the software-defined configuration of the circuits. So when, for example, Momentum has a performance issue, the SD-WAN immediately picks up on this and fails over to the other circuit. And these metrics are measured based on their ability to reach the EUS1 AWS endpoint. This is configured through us. And, as I mentioned, instead of this only being a manual test done yearly, it's done constantly all the time. And the only way this works is if both circuits are live, and that's where the active-active comes from. But at any one time, you're only going to have traffic going over the best circuit that gets you to the AWS EU West region. Yep. Was there a question?
Nothing. Yep.
Okay. So for example, before Momentum was having issues, Colt was actually having issues prior to that. And the SD-WAN, this was say a couple months ago, was prioritizing all traffic out through Momentum as Colt experienced the upstream circuit issues. And this, goes back and forth live and is uninterruptible. And I think it's important to bring this up because we're having conversations about, if we get another circuit that utilizes Telstra like Colt, is that going to be a fix for, having Momentum? And the consensus there is it's a shot in the dark, right? We're still going to be in the same situation where there could potentially be an upstream middle mile performance issue. And, we could get, 5 different internet circuits. And yes, it would bring the percentage and likelihood of this down just due to the various options, but it's not going to be a guaranteed fix. When I had emailed the two of you on last Monday, I believe it might have been, I had proposed a absolute solution that would have been the direct connect circuit. After some review, myself and team don't feel this is the appropriate solution. Not to say that that wouldn't absolutely fix it, but when we look at the likelihood and the scenario of what we ran into, this is really a kind of a Murphy's Law situation in that we had an absolute problem with Colt and the performance issue with Momentum at a perfect time. And if I were to say the likelihood of that happening again, it's slim to low. But we're also in the middle of a project that looking to help alleviate this issue. Meaning, if we were to move forward with the direct connect, it would be an expensive cost to justify. And this was a outage that cost us money, right? But we would be saying conservative estimates, maybe around $4K a month to add that direct connect to alleviate this small likelihood situation that we ran into. Now, I don't want to jinx us. Colt could do something tomorrow, right? And they're doing construction and rip it up again. But what I'm trying to drive at is I think what we have in place with our AWS CloudWAN project will help facilitate this problem, because what it's going to do is alleviate the middle mile. I'd like to, if I can for a second, I'm going to try to freeform draw here, so bear with me. I'm not a great mouse drawing with mouse artist, but it might help some of the
So, Michael, just while you're calling it up, I'll try and paraphrase something you said a second ago, just to make sure I've understood correctly. The active setup. So, I'm picturing we have 2 pipelines that are open, they're both active, and the algorithm is making an instantaneous decision based on accessibility from current location through to EU West as to which one of those pipelines is used for a package of data at a point in time. And it might say, in this instance, Colt's the best, or Colt's the one that's active. And for whatever reason, in the next instance, it might determine that Momentum's the best, but it will jump between one and the other as it sees fit based on the performance of that pipeline to deliver the package of information from our location to EU West. Is that effectively
that's correct?
Okay.
So,
and it's doing that multiple times a minute, hundreds of times, or 100 times a minute, whatever that might be. But every second or two, it's doing it.
Yes, that's correct. Okay. So, let me say this is you guys here, and this is AWS EU West. There we go. We have, the way this works is, imagine these guys here being the two circuits. Yeah. Okay. Yep. So let's say this guy here is Momentum and this guy is Colt. What is, in a sense, what we have is this SD-WAN here, and let's see. And this is all traffic going in and out of Deer Park. This SD-WAN, or it's SDN technically, software defined networking. What it does for us is acts as the option anytime data needs to go out to connect to the EU West. This is the metric we've configured. We can pick any like metric. We can say maybe it's just Google, maybe it's just, you know, etc. But you know, it makes obvious sense. It should be, you know, production traffic, and this is what we configured.
Yeah, and EU West hosts most of our services, which we use in the shop floor.
That's correct.
Yep.
So this comes from our transition from the monolith. If you remember, we used to have the Dublin data center. That is where previously all your production workloads were executed. And under that architecture, under the monolith, we didn't use the internet at the time. We used the MPLS. And the MPLS is a private, meaning no public internet, direct physical connection from Australia to our Dublin physical data center.
Yeah.
When we transitioned to the cloud, that traffic moved over the internet. The challenge with the internet, as we're all aware of now, is what's called the middle mile. The traffic that goes past, so we have what's called the IEX, the internet interchange that our carrier is going to use to get into the middle mile. Every provider has one. And how they get, so this would be the Lex traffic, you know, from here to here. And this would be the middle mile traffic. And on the other side of this is what would be AWS's
exchange.
Yes. And when we have, say, this is Colt and this is Momentum, when we open a ticket and say, you know, we're having performance issues, they'll only check and work with us on this part. Once the traffic starts to transport over this middle mile area, it's considered best effort, and that's in our contracts with each provider. They'll say, you know, everything here is best effort. So when someone gives you an SLA and they say, we'll give you 99.995% guarantee, they're only guaranteeing this first part here, and everything after is best effort. And we have no, well, this is not entirely true. We have some availability with AWS on this side, but honestly, their infrastructure is so grand, it's zero likelihood we're going to have issue, because they similarly have extremely advanced SDN. So they're giving us the best path in and out of their cloud data center, which is in Ireland, at all times. So, yeah, like I said, this is kind of how things look and work. And the SDN is checking these links at all times. And what we had happened is Momentum, you know, had a, what would be a good, I don't, sorry. I lost control, of course.
So Michael, while you're doing that, the lines connecting each of the IEXs from one side to the other, they're actually multiple parallel lines. I I imagine there's a whole lot of different service providers that Colt or Momentum would tap into, and perhaps even the same ones they would tap into. Is that fair to say?
That is. So let me call that up and show you what that looks like. I'm going to just share my entire window here. So hopefully you can see this here. Actually, it's the other one, I believe. I'm sorry. So when we see in the RCA these pictures, and what this test is telling us is each hop here is an individual hop across this line. So that's so this is where Momentum relinquishes responsibility. Then it goes to another hop, to another provider, just that exists publicly on the internet, and then another provider, and then another provider, and then bam, then this is where we see, if you see here, packet losses and how they increase. This link where it's being reported is out of everyone's control. So this is helpful, and this is one of the reasons we went to implement SDN at all our plant sites, is to help alleviate this fact, because again, the old way we had this configured was the switching between these two was very manual, because only a complete outage, you can't get to one over here, would cause a failover. For performance issues, there's no traditional networking configuring option outside of software-defined testing that can pick up on these performance degradation. So when this happened, and this will be Momentum again, say, the SDN started sending all traffic through here, and then what happened was Colt had an issue where this was hard down. Now the SDN knew this was still performing bad, but since there was the only circuit, it was sending all traffic through here.
For that, yeah.
So what I had initially said in the email was, we will send a direct connect, which would be Amazon's version.
In Sydney.
Yes. So this would be like this.
So it no longer need would the SDN then sit across that and the Colt line?
Yes, we could do something like this.
Okay.
However, we don't need to. So what this would ultimately do is all traffic that needs to go over the public internet, say your Salesforce, your Google, Facebook, YouTube, anything and everything.
Email, other services.
Yes, Google Workspace, that would still go over here, but anything destined for here would now take this physical new route, and it would go directly into AWS. This is now AWS's infrastructure,
Yep.
and it would go straight to the region where your services are hosted.
It might be a moot point, but would that be an IEX at each end of each one of those two lines as well then?
No, because
just
it's not
straight
even, it's not even utilizing so to a degree, it would still use, say, Telstra's network to get to here, but it's
Yep.
all private lines now. So it's different physical circuits
Yep.
being utilized, and there's an absolute SLA across all of this. So unlike where we
The
use,
entire path.
yeah. But here's
And
the,
definitely with Amazon's own bigger bandwidths, like they will definitely have data center, test center, like much higher kind of
yes, and
connectivity.
if there's an issue right here, call Amazon in 5 minutes, they're helping us. But here's the, again, the problem with this. This scenario we ran into over here, this is the first time it's ever happened across all sites.
Wow.
So the likelihood that this will happen is small, but not impossible.
Yep.
This solution would be an additional 4 to 5K a month to
Is
cover.
that US dollars you're picturing in your head at the time, Michael? It is.
Yes. Yeah.
Yep.
So
So at the moment, thinking out loud, and I take your point. I absolutely take your point about the low to no risk of it occurring again. Just from a cost perspective, just for a second, 4 to 5K a month for the direct line. We spend, if I recall correctly, the Colt line is going to cost us about 5,000 AUD a month, which is 65% of 5,000, about 3,500 USD per month. And the Momentum line is about 4,000 per month. Momentum, surprisingly, is a little bit more expensive. So Momentum is about 4,500 per month.
Yes.
So going back to our discussion the other day, if we decided that was a path to head down, then ideally we'd drop the Momentum option from the picture, run with the Amazon Direct with the Colt as it is now. It would cost us an extra 12 to 15 grand a year as a site, Australian dollars as a site. But
so here's the
and to your
challenge.
point, do we need to go through that process of making that change if you've got other solutions on the?
Yeah, so basically, our question is: do we in future, and if the plant accepts this AWS, which obviously we want to do.
So let me finish, because I think.
But if Michael's saying we may not need it, then
Yes. So let me explain why I think we shouldn't need it. So this issue over Colt was a physical one. This happens extremely rare.
Yeah.
These happen, the middle mile ones happen all the time. Like I said, a month earlier, Colt had an issue in the middle mile and Momentum was clean, so that was being used. We have in progress a project called AWS CloudWAN. What that does is, instead of having this physical infrastructure directly built into Deer Park, we're bringing AWS closer to you, so you don't have to go through this middle mile. The private AWS infrastructure is now hit right before it traverses this long geographical distance, and this is now still AWS's physical infrastructure. So you'd still have the LEC issue possibility, but that is still the responsibility and onus that we have in our contract with the providers, so that issues still can occur up here, but it won't impact us because it never gets to this area of traffic in what's called the latency, the time it takes a packet from here to get to here and here, your ultimate destination, is reduced, I would say, approximately 50%. So where this traffic would take, say 100 to 200 milliseconds, have these packet loss and jitter statistics. See how right here, number 7 and number 6, see how good these are before it goes into the middle mile?
Yep.
You would stay that way because you would be going to AWS's infrastructure first, instead of transitioning over any of these two. Also, the challenge with the direct connect, if we were to do this, we still can't get rid of either of these circuits, because technically these are still separate, meaning Momentum is taking a first mile, the LEC, different route to the internet. If we were to get rid of this to save money, the only thing we can send over the direct connect is AWS traffic. So your Google Workspace, your YouTube,
Internet. Yeah, normal
yeah,
internet.
any internet.
Still-
Once this happens, your entire site's down. The only thing that's working is AWS, but you use more than just AWS to have a properly running plant location. So
Yep.
we would still need this, and we still need the what's called the LEC diversity,
Yep.
the ability to go a different route to a different internet exchange to
Okay.
have the high availability you have.
Michael, I have a question.
Yes.
So definitely we need two links. We cannot afford the single point of failure. We at least need two. That's one thing. The second thing is in this diagram, you're saying the contract, for example, we pick Colt and we go to AWS direct link via Colt in our contract, right? My question is that AWS, like for example, if the Colt line again is cut and it's really hard down, do we need a second contract with Momentum, for example, as an ISP to route the AWS direct line? Is it the two contracts? Like, how does that manage?
No, so this, let's reframe this.
So, or is it just internet and it just via internet is just like a one more middleman?
So either of those IXs could route across to AWS cloud. Yeah.
So AWS CloudWAN allows us to take advantage of both circuits
Yep.
without
Yep.
adding any type of price
Mhm,
increase between any of these providers. Like I said, it's going to stop this issue that we see here in these
Yeah.
pings, which happen all the time.
And Michael,
that's-
is it the SDN that's still making that decision at that point in time? The SDN is assessing the quality of the lines and then telling it to switch, or?
No, it's us. So this is Sydney's so AWS has physical infrastructure for their
Sydney.
cloud in Sydney.
Yep.
And us building this is all configured in here. So that when you're here and sending traffic this way, it knows I can go instead to Sydney instead of having to go to EUS1 to get to Web Show.
Yes, which is using EOS. Okay.
So this lives in EUS,
True.
but the path to get there, and I know it looks, so the challenge is these are just lines, but I want you to imagine these lines actually being 10 times, 100 times possibly longer than these. These are very, so, but this line here is all back-end AWS. So AWS will take the traffic, and just like we used to have the MPLS, it sends this at an extremely fast, low latency, no packet loss, because this is the service we're buying from AWS,
Yep.
is to have this ability to send this here. What could happen is still Colt could dig things up, but in the same scenario, since we have this now, we would lose Colt, so no AWS traffic would go through there, but we'd still have momentum. And even though they'd have bad upstream performance, it doesn't matter because AWS
we get through the
CloudWAN
cloud.
is sending it to here through this low latency connection.
True, because web shell and those kind of softwares are more prone to packet loss versus somebody opening an email. They will not really realize
You are
anything.
actually right. You
So
are absolutely right.
So,
Yeah.
Michael, one more question. So, if we move forward, how many contract renewals are involved in it? Only with
None.
Amazon? Only via Cold plus Amazon?
Only
Like-
Amazon. So what we're paying for here is Amazon charges you traffic. So the traffic we're sending over this link is going to increase our cloud costs. We've already, in networking, accounted for this in the project proposal and budget of this season. So for you, actually, I don't want to speak 100% on that. To say there's no cost, there may be some chargeback to this cost, but it's going to be minute, nothing compared to a new physical circuit. And this is why. So what the trade-off we're getting between this and a direct connect is we still risk the possibility of a Colt happening. But since we have two circuits, we reduce that exponentially. And this is the
the only scenario it wouldn't cover, Michael, is if we, by pure miracle, both Colt and Momentum had the backhoe issue or something similar.
Yes, you're exactly right.
Should be incredibly rare.
Extremely rare. What would happen in this scenario is this site has no power. There is something more serious going on in this scenario than worrying about web show. A scenario like this would be coincidentally what happened in Spain. Half the country lost power. That would be the situation where you see this failing on all scenarios. So this is the reason I wanted to, run through the RCA, help explain what happened, how we hit that scenario. And while, yes, I think my statement before was, if you would have asked me, your life depends on finding a solution to absolutely fix this, I would say, oh yeah, it's direct connect, because this is the most expensive. It's a unique physical infrastructure. It avoids ISPs altogether. But since the scenario we ran into is such a rare occurrence, we're maybe talking in the 1% likelihood over the course of the history of the site. I think this is the more appropriate solution for us. And the project's approved, it's underway. It's just going to take some time for us to get to a point where we're now routing all your AWS traffic over this optimized route.
Yeah. And without holding you to a strict time frame, Michael, what's your estimated time frame? Are we talking 12 months from now as an example, or sooner or later?
Our optimized, actually, I don't want to again misspeak. We have a 2-hour project planning meeting tomorrow. Okay. And after that, I can give you a better estimate of when we can turn this around. Best case, we can get your traffic in a more optimized region within 4 to 5 months.
Wow. Okay. Impressive.
So, yep, I think, but again, I don't want you to say that I'm promising that, because I think there's going to be.
I understand. It's best guess at this point in time. There's more discussions to be held.
Yes, exactly. So
Michael, one thing, yes, thanks for that. But definitely this incident happened, I would say, a few days. But as you started your discussion, that luckily this happened because it is a very rare occasion in history of 14-15 years. We didn't had this kind of one line is fully down. Always we were operational in a way or so. Yes, things were slow, but now as we depend more on web shell and time sensitive, packet loss sensitive incidents, we have been experiencing some slowness for a while in all kind of web shell related softwares which we use. Sometimes the label is a bit slow, but when the operator is printing hundreds of labels a day, they can quickly compare, or yesterday it wasn't that slow versus today, so they complain to us. I think going forward to this Amazon direct link kind of way will improve other things also in the shop floor. It can decrease latency, so it's a win-win situation. But again, this incident, a lot of upper management their eyes are on here, and definitely we need a plan, which we need your help in it. Like once you send, and would like to have it from you, that Himanshu and upper management has, and obviously Grant involved in that. That what is our plan and how can we quickly implement? Because again, uh, my department is being asked that, okay, this has happened, when we can see improvement, or if what's our plan. So obviously this is part of the plan, but this will definitely help us
So
moving forward.
I think we've, to answer that point on Michael's behalf for a second, we'll, and jump in, Michael, if I'm getting near this.
Go ahead.
One of the things I worry about is, as a business, and not just with instances like this, but we're trying to eliminate every risk. And I don't think that is ever fully attainable, and I don't think it's realistic. So, I think we've got to go through a risk assessment process that if you get an incident like this that is very rare, it can have an impact, but it's very rare. There should be a question asked, but well, do we actually have to change anything? Maybe we don't.
Mm-hmm.
The intention that Michael just went through there is we're still going to look at making the system more robust. We've got a 4 to 5 month window before some infrastructure modifications or adjustments are made to improve our situation, and that might not be the ultimate long-term fix, but it's going to reduce the risk even further again. So I would suggest that our conversation with Himanshu and the team here in the first instance is what we saw was rare. Clearly, it's not impossible, but it's a rare. Michael and the team are looking at alternatives that will help make it even less common, or will make it more rare again. And Michael, I'm interpreting what you've said. I might have this wrong, but it's kind of I'm picturing a 2-stage process. There's 4 to 5 months where you're talking about the regional capability, but it might be another period after that before what you showed on the screen is ultimately in place. Is that correct?
No, my 4 to 5 month estimate is when you'll see performance to all AWS endpoints like Web Shell and everything else.
Sure.
So
So 4 to 5 months is and effectively what I'll call the end solution at this point in time.
Yes.
It's terrific.
Yeah. So again, there's no new physical infrastructure in this.
Yep.
What we're doing I'll send you the links, but we have explicit write-ups about what this is, the architecture involved, the steps needed at a best guess estimate right now. As you can see, the complexities for us are in the back end, making sure we're routing and configuring the HA of the plant priority traffic. So I think, Maz, you said, we'll see other performance increase. You're absolutely right. Everything that lives in AWS is now going to perform faster for you once we get this new architecture in place, because this line here, and it's latency we're looking at. That's the time it takes a packet to get from Deer Park to AWS. Right now, that's probably, since it's going over this huge geographical distance, that can be anywhere from 200 to 800 milliseconds. A sensitive application like WebCell can't handle that type of latency. The new latency, because this is private infrastructure and we're getting you there really fast, it's probably going to be averaging around 100 milliseconds, sometimes less. And we're going to look to optimize that. And we're going to add other options such as an HA availability where you will have, should Sydney go down or experience issues, you will say go AP South 01, India. So you'll have this type of regional capability as well. This would be, say, in a scenario, again, where Spain lost half their power, right? So if Sydney lost power, say the city, we could still get you to AWS. Realistically, you're probably having some issues if Sydney loses all of its power, but nonetheless, we're adding in this type of geographical redundancy as well, so that now instead of a 500 to 800 millisecond latency, which, by the way, there is always packet loss over the internet. The average packet loss is 10%. You hit 30%, and that started to affect web shell performance and other things. Packet loss would be close to mitigated across this because the packet loss over the LEC is little to none, 1% at most. 1%, you could probably open a ticket with the provider. But once we hit the AWS CloudWAN, there's absolutely zero packet loss jitter and other statistical inference you see over public internet. So this is a robust solution. Again, it doesn't solve things like this, where there's a LEC issue, which now this is the absolute responsibility of both Momentum and Colt. You know, we should get some type of credits from Colt for them, you know, digging out and causing that issue. It won't affect a absolute local issue in Deer Park, like if there's hardware or other things. We have some hardware redundancies. I don't want you to think there's nothing there. But again, if like the MDF rack had a power issue or some type of large scale failure. So I think, you know, this mitigates it quite well, and also looks to address the underlying problem, which started us in networking pursuing the AWS CloudWAN solution, is that the general latency and performance of the internet is not good enough for you or other sites. We see issues in Bawandi, Montego Bay, you know, the other care and plant locations. We're giving them this high latency CloudWAN connection option, mitigates and relieves all that, so that, you know, new applications, things sensitive to latency, fragmentation, and other packet interference that occurs on the internet won't be applicable.
It sounds terrific, Michael, and I think that would allay all concerns for the broader business here.
True.
Are you happy to send through that the sketch you've put together over the?
Oh yeah, absolutely. I'll send that, and I'll also send the if you want a boring late night read, I got it for you here. And this is the architectural solution of the AWS CloudWAN project.
I will definitely read through that.
There is some project notes, but please don't. Again, the timelines are not written in stone. We're going through that now, but I'll look to keep both of you up to date as we make progress with the WAN solution. And now, you know, for better or worse, there's a lot of visibility on it. So I think, you know, any type of previous roadblocks we may have encountered are going to be alleviated. And there's hopes that we can get this in place for you guys as soon as possible.
Yeah, I think that's terrific, Mike. And I think ultimately, for the purpose of the broader team here, Moz and I would probably step through the diagram that you just put together for us while we were talking with the leadership of the business, and talk about a 6-month time frame for delivering the AWS CloudWAN solution.
I feel confident in a 6-month time frame with this.
Yeah, so we talk to that, and there'd be, to be honest, I don't think we'd hear about that again from anybody in the business here, unless there was another issue coincidentally.
Yeah. And again, I think this is a good reference to say, you know, these ones between the IXs, we have no recourse for, right? Yeah. It's and
that was the area I think you described it as Momentum at their end, quite rightly, couldn't see issues because those issues sat outside of their area, which is, if it was with them, it'd sit between the SDN and that first IEX on the Momentum line. Is that correct?
Yes.
In that,
Let me,
arrow,
I could draw this out a little bit better to say, you know, here. So these blue parts are what they'll help us with.
Can actually own and impact any issues directly.
This black part of the line, no one has any ability to adjust.
Yeah, it's in the wild.
Yeah.
So And what this realistically looks like is more like this. The IEX is where the circuit sends the traffic into the middle mile, this part. What AWS CloudWAN is, it's taken the traffic before it even reaches the IEX. And this can be, again, seen in these, latency calls when we start to see traffic drop. That is the issues we're seeing up here. The clean circuits are down here. I'll add them. I'll move these to right here just to say, if you're relaying this, I would articulate it as we reach AWS before we get to the internet exchange and lose the ability to control traffic.
And that's that's a manual process. I think you said before, we control that. It's not the SDN at that point in time. Is it, we recognize there are issues on the internet portion of the Colt line or the Momentum line. The area between the IEXs, we've recognized there's an issue, and at that point we switch.
Yeah, so the SDN is looking at the entire path between each and how it gets to. So what it's doing is this, consider this the test. It's testing this, and this all the way to web show. And if, let's take these out of here. If this happens on this circuit, it prioritizes this one and vice versa. And this has happened quite a few times since we've, well, maybe 2 or 3 since we've implemented, a couple, maybe 6 months ago. Now, it's the SDN is still going to help us with this, because we're going to still check to make sure we're getting the best route. But now it's going to do something along the lines of, well, maybe there's a reason to go to India instead of Sydney. Like I said, this would be low.
Whatever reason.
So the SDN can still come into play, but it's less likely it's going to move traffic around, because this, directly is going to be the most optimized route. What it will do is, say this all goes away, it's going to be able to send this back over the internet now.
Okay.
So it's almost a tertiary option between the two, and that's why the architecture of everything gets so complicated here, is because we have to configure this dynamically for all traffic,
all the different scenarios that could play out, any path failure at any point along that path.
Yes, exactly.
Okay, Michael, one last question from me.
Of course.
When the most recent issue came up with Colt, it was understood that the Momentum line had been having problems for a couple of weeks by that point in time, and that is what it is. I think discussions between us and maybe Nitesh at the time were around the lines of, Momentum was a problem, but we didn't know anything about it. That's okay. Would we have done anything different in any case? Like, there's nothing we could have done in that scenario, I'm taking, given what you've described today in any case,
We took action. We took it 6 months ago when we implemented the SDN, because what was happening was this was occurring. We were having upstream issues, but without this, we required that manual intervention. So you're like, let's put it SDN, let it pick the dynamic best path across the circuits, and that's what it started to do. And this is where the complexity of Colt having this issue here and us having this issue here just made a disaster scenario. It would have just have been likely where this situation could have happened, and we would have been fine. If Colt dug up the circuit 3 months ago, no one would have noticed an issue, because Momentum would have still been prioritized as the best path for web show traffic. But since we had the middle mile issue here, the LEC issue here, we would just, you know,
Just start.
Murphy's Law or just
Yeah.
whatever you want to call it.
Whatever it is at the time.
Yeah.
SDN, the software, is it software determined networks or software decision?
Defined. Software defined
Software
network.
defined network.
And this
Okay.
exists on your Palo Alto firewalls. You have two of them. So what it does is this is a software that runs on the local egress devices and chooses through those tests I mentioned. It's
Yep.
constantly testing each to this location. And it's saying, you know, whoever has the best path there, you know, which right now is Colt. And the complexity of this is what why we see this is Colt takes one path to get to the EU. Momentum takes another path. Momentum goes to Singapore, and Colt right now has been going over the Pacific to the US to the EU.
Okay.
And
different directions. Yeah.
yes, so at any one time, that middle mile here could be better or worse based on just the state of the public internet. We want those two different options. Like I said, if we were to replace Momentum here and say, all right, let's get something as good as Colt. When this happens, you're entirely down. And actually, when this happens, we're entirely down because we don't have another way to get there. You know, but we're always taking the right turn to get to that location. We don't have the option to go left at any point in time.
Yeah, that makes sense. That makes sense.
So,
Really good explanation, Michael. Thank you very much.
Thanks, man.
Again,
of course, yeah, happy to
thanks,
help and
thanks for hanging
clarify.
around so late at night, your time. It's usually us getting up super early to catch up with people out of the state. So I appreciate you doing it the other way around for us. Thank you.
No, of course. And, you know, this is nothing for me. You know, if this hour, this 2 hours, whatever, helps us avoid, say, you know, 4 days of late hours, early mornings between each other, it's all worth it, right? And
good investment. Yeah.
Yeah. So, I just want to say, of course, I can't promise that disaster scenario that we just had, because we still see the performance over Momentum being worse. Now that may change in a couple of weeks when the SDN says, hey, now it's actually better over Momentum because Colt did something, I don't know, and you know it's migrated over. But I feel confident that the solution we'll have for you in 6 months is going to mitigate the likelihood of that happening so well that it's beyond Murphy's Law. We're going to have to invent a new law for this scenario because we're talking in like the 0.1% likelihood. And as I mentioned, it's something grand in that scenario, like, you know, there's a regional infrastructure problem near you that's affecting everything. And, you know, at that point, you probably have bigger problems to take care of than, you know, traffic to AWS, right?
Yeah, that makes a lot of sense. And we have, in Australia at least, we're unlikely to lose the whole country at the same time, or even half the country at the same time through power outages, but we have had major city issues. There was an issue in Adelaide 5 or 6 years ago where the entire city and a lot of the surrounding areas lost power. So we can lose power. The scenario that you spoke of, we could lose power where we are now, and that would take out both lines. We could lose power in Sydney, and that would take out the Sydney,
I think that gets back to the point you were articulating earlier. There's nothing we could throw billions at this. Well, actually, billions would probably just have us buy AWS and we just live in it, right? No, but I'm saying we can throw so much money at. Yes, exactly. So this scenario and this plan with AWS and the project we have in place, I think puts us at such a low risk that if
it did come to fruition, there'd be bigger issues at play. There'd be something else that was so big it would be creating a problem for that and would have side effects for us.
True, no worry. Thanks, Michael, for the time and explanation. At least it gives us a confidence, I will definitely say. And then when we talk with the management also that something has happened, we did a post-mortem, we have a plan, we have a timeline kind of estimate, and at least this gives them confidence that as a production or a business, what we are doing. And as I always say, your team is very helpful all the times and
Yeah.
professional. I don't have any doubt that what you guys are dealing with, that I will have any issues.
Yeah, and you know, I'm really doing the easy part here, to be honest. I think I'm just articulating what my guys have spent a ton of time and work doing, you know,
Put a lot of
and
effort in.
really a great praise. If you're going to give anyone applause here, it's you know, Nitesh. He really he not only helped in this scenario, but he's been critical in the AWS CloudWAN architecture and the work, and he's leading that project himself. So, you know, all applause from my end, you know, goes to him. But also, you know, I want to thank you. You know, it can be challenging to have communications of cross geographical, you know, time zones, and when you know in these critical and tough times, it's easy, I think, to kind of freak out and, you know, run around. And, you know, I really applaud, you know, us all being level-minded and looking to really look to get to the source of the problem and alleviate that. And, you know, I think the collaboration across both teams has been great.
Excellent. That's good. Thank you.
Thanks, Mike. Thank you very
All right,
much.
I'll
Hope you get
send
some
the
sleep.
yeah, I'll get some sleep, but before I do so, I'll send you the links with the documentation for both the diagram I made and then the links for the actual project if you would want to get a deep dive into how that's going to work, technically speaking.
That'd be terrific. Good on you, Michael. Thank you.
Yep, have a great one,
Thanks,
guys.
Michael.
I'll talk to you
Good
soon.
night.
Bye-bye.
Bye.
I got caught up on the way down here.
Sorry.